In the figure here, point A, B, C, D lie on the line. We can see the points A, B, C, D, where AE is the diameter of the bigger circle, AB is the radius of the smaller circle, and so on. A is on both the circles, B is the center of the smaller circle, C is the center of the larger circle, and D is on the smaller circle, and E is on the larger circle. What is the area of the region inside the larger circle and outside the smaller circle? So we need to find out the area inside the larger circle and outside the smaller circle. That means we need to find out this area. So in order to make this figure slightly more comprehensible, I'm just going to enlarge it slightly. So let me just bring it here. Let me make it slightly bigger, such as this, because now I'm going to mark here all different values. So let's start with a few numbers. Let's assume that the smallest radius is equal to small r, so we can say this distance is small r. And now we know that BD, because D is this point, BD will also be small r. And let's say that the radius of the bigger circle is capital R. Now BC can be written as capital R minus a small r, right? We know that CE is also equal to capital R, because this distance will also be the radius of the bigger circle. And about CD, we can find out that CD is equal to twice of small r, because AD is the diameter of the smaller circle, which is 2r, minus AC, that means capital R. And similarly, if we need to find out the length of DE, we can again find it out. DE can be written as twice of capital R, because twice of bigger radius, minus twice of smaller radius. So now we have all these things in terms of capital R and small r. Now we need to find out this shaded region, and this shaded region, the area that the question is asking, is equal to the bigger circle minus the smaller circle. So the shaded area is equal to pi capital R square minus a small r square, which means we need to find out capital R plus a small r and capital R minus a small r, and we will be able to answer this question. Now we have to see the statements and see how the statements are sufficient or not sufficient to answer the question. Let's check the first statement. The first statement says that AB is equal to 3 and BC is equal to 2. So AB, that means the smaller radius, is equal to 3, and BC means we can find out the capital R is equal to AB plus BC, which is equal to 3 plus 2, that is equal to 5. Now we have the capital R as well as we have the small r. That means we can simply substitute it, and we can find out that the shaded area will be equal to pi times of capital R square minus pi times of small r square. The small r is equal to 3. So we find it out that this is 25 minus 9 pi. That means we have 16 pi. So the first statement alone is sufficient to answer the question. That leaves us only two choices, A and D. Now let's check the second statement. The second statement says CD is equal to 1. So CD, we already have written that twice of small r minus capital R is equal to 1, and DE, which is equal to twice of capital R minus twice of small r, is equal to 4, which means we can once again simplify these two equations, and then we can find out the radius. For example, if I just add the two equations, then minus 2r will cancel out this plus 2r, the small r, and we have r is equal to 5. Now since the capital R is equal to 5, small r will be equal to 3, and once again we can do the same calculation. That means the second statement alone as well is sufficient to answer the question, and therefore the final answer for the question becomes option D. Thank you so much.